welcome. My name is Steve Ellzey. I am the president of Your Sanctuary Productions, and we are here in the YourTown studios talking to Dr. Andrew DeVogelaere. He is the research director for the Monterey Bay National Marine Sanctuary. Andrew, welcome. Thanks so much for taking the time.
It's great to be here, Steve.
Now, research director over there, so you oversee a lot of the research that goes on under the auspices of various scientists that are working for the sanctuary, or?
Yeah, so the sanctuary is a really large place. It's
Right.
about 6,000 square miles along the central California coast. And so we have some science staff in our office. And what we're supposed to do is provide scientific information to educators and decision makers to help them do a good job with their work. But maybe more important than even my work with the staff is we have a huge cadre of scientists up and down the coastline here, and I'm supposed to work with them and get their science integrated with the needs of the public and the kind of decisions that need to be made to protect marine resources.
Considering that, you're the perfect person to answer this question.
Okay.
Is this the most researched stretch of ocean in the world, or close to it?
You know what? I could say with confidence that we have the highest density of marine scientists anywhere else in the world. So around the Monterey Bay, we have up to, depending on how you count them, 50 different marine research institutions. And they're all focused on this area because it's spectacular for its diversity of habitats and animals. And so we're blessed with a lot of great minds and scientists to help us out here.
And that must keep you smiling a lot with all these smart people running around and doing some cool things.
Yeah, definitely. I mean, it's they're a vibrant community to interact with. These are really bright people that are passionate about their work, and it's motivating to be around them.
What does it take to get to where you are right now, Andrew? Did you start thinking about this when you were in school, or?
Well, you know, when I was a kid, I was interested in goldfish, and I was interested in breeding tropical fish.
Wow.
You know, that was kind of middle school and high school. In college, I got interested in marine ecology, and so it wasn't in particular just one species that I was interested in. I was interested in looking for patterns in the ocean and on the shoreline and seeing what causes these patterns. So if you see a lot of animals here and not there, note it and then try to figure out why it is. So I was interested in broader ecological questions, but then using the marine habitats to understand them and figure them out.
If someone wanted to be a research director or a research scientist, is there a path that they follow?
No, there isn't. There isn't a path. You know, I've noticed with a lot of my friends and colleagues that it's not like some things like engineering where you'd say, if I go to school, I have this interest, and then I will end up doing this, and I'll have these opportunities. It's more like I'm passionate about marine science, I'm doing what I love, and then opportunities open up, and then you take sort of what you can get and build it from there. So some of my friends, when they graduated, well, the Monterey Bay Aquarium opened up. They started working there, where there is an oil spill prevention and response office that opens up for the Department of Fish and Wildlife. So you kind of have to be willing to maneuver, sort of like catching a wave as a surfer. You're ready, you're paddling, you're looking around, and then off you go.
So the key is be in the water.
Be in the water, be ready, and also be aware, you know, develop connections, get to know who's doing what, work with your friends that are doing different kinds of research so that you become broadly educated, and then you're ready to take advantage of opportunities when they arise.
Fantastic. Now, you mentioned partners before.
Yeah.
Talk about some of the partners that you're working with then.
Okay, so we have a website for the Monterey Bay Sanctuary that tracks the major monitoring programs going on in our region. So we have network partners that have contributed to this website to say what they're finding, general trends and some images. And we have over 100 of partners involved with that.
Wow.
So we have a lot of people we're working with, but I think about it largely in terms of habitat. So our main partner in terms of estuaries, the Elkhorn Slough, is the Elkhorn Slough National Estuarine Research Reserve.
Oh, okay.
Right. So there's scientists that focus on estuarine science. We work with them. They sort of take the lead. If you go down to beaches, we have a fantastic citizen science program that we help set up, but is now largely run by Moss Landing Marine Labs at Cal State University. And our volunteers survey all the dead birds and mammals on the beaches once a month. You can learn a lot about what's happening in the ocean. As you go further down onto the continental shelf, which is the muddy areas offshore, we work a lot with Cal State Monterey Bay.
Oh, okay.
In fact, I'm adjunct faculty at Cal State Monterey Bay, and so we do a lot of work with them with towed camera systems, and we're developing an archive of all of the videos for that area at Cal State Monterey Bay.
Wonderful.
And then in the very deep, we work mostly with the Monterey Bay Aquarium Research Institute. They have fantastic ships and remotely operated vehicles that can operate down to 12,000, 15,000 feet. But they're a nonprofit funded by the Packard Foundation. So we have a variety of partners from state to federal to different marine labs, and then nonprofits that we work with.
Yeah, to the beachcombers and that are walking up and down on the sand. That's wonderful.
Right. That's right.
And a sanctuary is about a community as far as that goes. Now, but for your specific passion, do you have any area of the ocean that really, really excites you, or are you just excited by the entire ocean?
I guess I'm blessed with a sort of an excitement about all of the ocean. I started off doing my research on rocky shores mostly.
Okay.
But then when you're working for the Monterey Bay National Marine Sanctuary, it's all the habitats within this large area. And I can't just continue my research focus. I have to look at everything. And I started getting involved with these birds and mammals and getting involved with that. Now I'm heavily involved with sound in the ocean. But what's a real passion for me now is actually working in the deep sea.
Okay.
Because we get to see things that nobody's seen before.
Yes.
You get to be the first eyes to ever look at a certain corner of the world. And there's a lot of excitement to that.
Absolutely. It is. It's deep space. I mean, deep ocean is deep space.
Yes.
We haven't been there.
We haven't been there, and we actually know more about the surface of the moon than we know about the deep sea. So there's a lot of exploring left to be done, and now's an exciting time because we have the technology to get there more easily.
Now, I have heard about the canyon that's off the coastline here, the Monterey Bay Canyon. Is that the correct terminology?
That's right.
And how deep is that?
Well, the Monterey Canyon, it's one of the reasons why we have all these marine research institutions around the bay. The Monterey Bay Canyon, it's deep. It's along the lines of the Grand Canyon, but with a bunch of water on top of it.
Right.
And as you follow it down, it meanders all the way down to 12,000 feet deep. But what's exciting for the marine scientists is as they leave Moss Landing Harbor, by the time they finish their cup of coffee, they're in thousands of feet of water.
Okay.
Well, if you want to do that kind of research on the East Coast, you have to be on a ship for over a day to get to that depth. So we have a lot of access to the deep here in the Monterey Bay area that others don't have around the world. And the Monterey Bay Canyon is the best studied canyon in the whole, all the world's oceans.
Okay,
Yeah.
all right. And it's right here offshore then, which really makes sense. Now, does that canyon also, you might not be able to answer this, but that canyon also affects the weather, I've heard?
There was thought that it influenced upwelling,
right.
Which is bringing cold, nutrient-rich water to the surface to create plankton that bring in all the animals. It turns out, though, that the wind and points like Año Nuevo are more important for that.
Oh.
But what the canyon does do is it provides a a pathway for sediments moving along the shore to get to the deep. There's these tremendous sediment flows down that canyon. And there's actually migrations of animals like sharks that go up and down the canyon. Wow. And interestingly, we have a huge whale population in the Monterey Bay, and they're there to feed. And the largest migration in the world every day is the migrations of millions of small animals that they rise up at night from the ocean, and then during the day they go down. And so what happens is they come up from the deep in the Monterey Canyon, they get shifted by the currents. On their way down, they get stuck on the continental shelf next to the canyon, and then so all the whales and the other big animals can come and feed on them. And that's one of the reasons why we have such a great whale watching industry in the Monterey Bay.
Okay, there's a turnover, a constant turnover of nutrients, which is a feast.
It's a feast. I called Monterey Bay the dinner plate of the Pacific.
Oh, wonderful.
We have shearwater birds that nest in New Zealand and then fly over here to eat. We have leatherback turtles, over 1,000 pounds, that lay their eggs in Indonesia, but they come here to eat the jellyfish. So we're a hot spot for food here.
And then you explain this to everyone. They may think of the deep water as an extension of the beach.
Yes.
And you told me a long time ago that's not what it's like, but please tell the folks what it's really like down
there. I think a lot of people walking on the beach, and they look out into the ocean and they just think, oh, the beach continues, and it's sort of this flat, sandy thing that goes down there. When I started working at the sanctuary in 1995, I sort of thought the same thing, because we had maps, a blue map of the depth, I'd say, oh, an airplane went down here, what was the impact? And I'm like, oh, I know it's about 1,000 feet deep. Let me call someone who might have dropped a grab down there and picked up a sample. But now we know a lot differently. We know that there are deep canyons like the Monterey Canyon. There are seamounts, these sharp peaks that go up. Some of the areas are sandy, some of them are cobbly, others are reefs. And so now we can see the bottom of the ocean. We know what it looks like in terms of topography and bottom type, and we can associate animals with these different areas too.
And you said mountains, sea mounts.
Yeah.
Davidson Seamount, which is what, about 70 miles west of Big Sur? Or?
Yeah, it's about 75 miles southwest of Monterey.
Monterey, okay.
And it's directly west of Big Sur. So it's a spectacular seamount. In fact, they used to call them mountains in the sea, and Davidson Seamount was the first one termed as a seamount by a famous cartographer named Davidson. Right, so it was named after him. And so we have an amazing ancient volcano, last erupted about 9.8 million years ago. And the shallowest part is 4,000 feet below the surface, and then it goes another 7,500 feet down from there to the bottom. So here in Central California, many of us drive up to Lake Tahoe now and then, and as you go over Echo Summit, it's about 7,500 feet.
Okay.
So we'll do that drive in 5 hours or so in a car. On the Davidson Seamount, in 4 miles, right? It goes from 12,000 feet deep to 4,000 feet deep. So you're going up 7,500 feet in 4 miles.
That's quite an incline.
Yeah.
Wait, was that a result of the volcanic eruptions?
Yeah.
And just building?
Building, slowly bubbling through time. You could sort of think of like Hawaii as a volcano building. But what's special about Davidson Seamount is that it's not circular like that. It's it's an elongate thing. So it's 8 miles across, maybe 26 miles long. And that's because over millions of years as it was developing, it was on an ancient earthquake fault. So it was getting spread while it was building. So we have kind of this a very unique shaped seamount here off of California.
All right, and I imagine with the water and all the currents and everything else going on, that's why things like that would happen.
Well, you mentioned the currents, and that's a really important thing about seamounts is while it's still 4,000 feet deep, they're affecting the productivity at the surface of the ocean, right? So what's happening is there are deep sea currents running along the seafloor. they hit the side of the seamount and then they go up. And when these currents are bringing up nutrient-rich water from the deep, black, cold ocean up to the surface, it hits the sunlight, the plankton start growing, the zooplankton start eating them, the small fish start eating them, and then all of a sudden we have a bunch of birds and whales over the seamount. So.
And that I have seen pictures of that and termed a feeding frenzy. Is that an actual scientific term?
Yeah, I think that's fine. I mean, you can see them. Some people say, "Oh, there's a bait ball or a feeding frenzy."
Bait ball, okay.
But you know, these animals, they're able to find food better than we are. I mean,
right.
I mean, think about you have a bird flying over the ocean and it's got to find a place to find a lot of food. When you and I look out there, it's like, wow, there's a lot of water. But some of these birds, you know, like albatross, for example, if you take a look at their beak, they have a special couple of tubes on top of their beak, and they can actually smell a chemical coming off the water that happens when zooplankton, little copepods, are eating phytoplankton. Chemical comes off, and they can smell it. So they zoom into these areas and they're able to find their food. So
no road signs.
No road signs.
No diner, next exit.
No, they use their nose, and I think the whales call each other. Some whales can communicate at low frequencies all the way across the Pacific. So these animals are well adapted to work in the dark and without a lot of sight to find their food.
Now, Andrew, did you just say whales at a low frequency can communicate all the way across the Pacific?
Across the Pacific, that's true. Blue whales.
Wow.
Well, they can do that. And we are studying sound in the here in the Monterey Bay. We have one of the few cabled hydrophones in the whole world, so we can hear sound. We're bringing in sounds and storing them on hard drives 24/7, and we hear things from earthquakes to rain to mammals. To
whales across the ocean,
right? And these sounds are from either high frequency, like squeaking, like dolphins, or really low frequency, like the blue whales. And these low frequency sounds can travel huge distances across the ocean, across the Pacific.
I had never heard that before, and it's happening. It happens right here in the Monterey Bay National Marine Sanctuary. We will be right back.